Welcome everyone. This is the Bridge Bearing Maintenance Training brought to you by the Bridge Preservation Partnership Local Agency Outreach Working Group. Jason, we really need to find a longer title to describe our group. We'll put that on our action item.
That's right.
Or we like acronyms, right? So it's the BPP LAOWG. Okay. My name is Travis Kinney. I work for David Evans and Associates. I have the pleasure of co-chairing this local agency group along with Jason DeRuyver, who is here as well. Say hello, Jason.
Hello.
And today I'm going to be co-presenting on bridge bearing maintenance along with Jonathan Boyle.
Hello, everybody.
Just a little housekeeping. This is a webinar format, so you are all automatically muted and don't have the ability to unmute yourself. Helps with the distractions when you get larger audiences like this. However, we still would love to hear from you. There is if you look at the little GoToMeeting app on the side there, or GoToWebinar app, there's a chat pod or a question pod. Jason, which one do we usually try and prefer? Do we try and use the chat pod or the question pod?
We use the question pod. So any questions that come in, I'll be looking at that and either responding or waiting until QA time at the end and asking you and Jonathan directly.
Okay, and I see some folks already using the question pod, so perfect. So please go ahead and use the question pod. These trainings, we've given quite a few of them so far. The content of the trainings is driven by the audience. So let us know what you'd like to hear about, and we'll make sure that we get it in the hopper for one of the future trainings. We just do these every other month, and they're just an hour long. These will be recorded, or is being recorded now, and both the video of us doing it as well as the actual PowerPoints will be published onto the Bridge Preservation Partnerships website. So we have a website that has all this training and then all the previous trainings as well. I always like to include at least one slide here to kind of remind folks of who are we. We're the Bridge Preservation Partnership, BPP, which is actually made up of 4 regional groups. There's the West, the Midwest, the Northeast, and the Southeast. Depending on where you sit, you'll fall into one of these different kind of subgroups. Our group ourselves are national, so we try and reach out to across the country. The partnership's really made up out of DOTs, local agencies, FHWA, academia, industry, and consultants. I will say it's a fairly unique group in the sense that, you know, everyone's trying to come together in a fairly diverse background, right? As you look at that attendee list, and just trying to find ways to extend the life of our bridges as cheaply as possible. Because in all my years of working with various agencies, nobody's told me that they just have too much money. So that's the purpose of this organization. A little overview of what we'll talk about today is we'll go through some backgrounds on all the different types of bearings, what happens when bearings stop working. That's kind of the piece of why do we care about bearings. And then we'll go through common maintenance activities for how to keep your bearings working well. And then bearing replacements. This is something that may be considered a little bit beyond maintenance, but certainly something that can be done by maintenance personnel. Or I've done it with maintenance personnel, and we'll kind of run through a case study of that. So what's the purpose of bearings, right? Really, their main purpose is to get loads from the superstructure, the deck, the girders, down to the substructure, you know, your cross beams and columns and abutments. With one caveat is they are intended to let the bridge move or keep it from moving, right? And in that let the bridge move or keep it from moving, there is a lot of variation as they try and either restrict the bridge from moving or allowing it to go. So bearings generally fall into 2 categories: fixed, which is don't let the bridge move, and expansion bearings, which are let the bridge move under movement. Or so the reason that bridges typically want to move is under thermal cycles. So when the bridge heats up, it wants to expand, and when the bridge cools down, it wants to shrink. And the forces that are generated as that bridge expands and contracts are tremendous. If you try and use some kind of a fixity or jacks or something to fight the movement, the loads that are generated are just massive. Fixed bearings can be a little bit misleading because fixed makes you think it doesn't allow any movement, but generally fixed doesn't quite mean that. Fixed bearings usually allow the bridge to kind of rotate about that. And when we say rotate, it's not something that with the naked eye you would see this big rotation happening. But as trucks drive across the bridge and they get out in the middle of the span, that span will deflect downward just a little bit, and that causes a little bit of rotation at those bearings. And so even fixed bearings allow some movement, usually rotation. And then you have expansion bearings, which have a wide variety. They can allow rotation, they can allow movement longitudinally, so that's kind of going in the direction of traffic, and then transversely as well. And they can either allow it or restrict it as that side-to-side motion. Some common types of bearings, if you were on earlier, I was kind of lamenting on the fact that there's so many variations to even each of these types. So this is an example of a slider bearing. It's a very simple system, and it's just like it sounds. It's allowing two plates to slide on top of each other to allow some movement. So if we kind of look at trying to categorize what this bearing does, we would say that it doesn't have anything to keep the girder from rotating, so it allows rotation. And then it allows the bearing to slide back and forth, so that longitudinal movement in the direction of the girder allows it to slide. And then what about transverse? Does it allow the bearing to go side to side, like something you would see in maybe an earthquake? And the answer is no. This has those steel plates on the side there that'll help keep it from being able to slide back and forth, and anchor bolts to transmit the loads downward. So no transverse. That's pretty common for a lot of our bearings, is we want them to keep the bridge from moving side to side, but allow it to expand and contract. Okay, rocker bearings. These are also very common. You got a sole plate at the top, which is just basically a stout steel plate that takes the load from the girders down into that rocker. And then you have what we commonly call a masonry plate at the bottom, which is that another very thick steel plate that helps spread the loads out as it gets into the concrete. So if we run through kind of our process of what do these ones do, it's a rocker, so it definitely gives us some indication that it'll allow for some rotation to occur. It's not fixed to keep the girders from rotating. It allows that longitudinal translation, at least to some limits. As it rocks back and forth, it'll let the girders grow and shrink. And how about transverse? This one's harder to see, but I'm going to say that it does not. There's very likely little steel, we call them pentles, but little steel nubs that are actually embedded between that bottom of the rocker and the masonry plate that'll keep that kind of pinned and unable to move side to side. Sometimes there's little channels that hold it, but I'm going to guess that that's not intended to go side to side. There is no better example of a roller bearing than this. This is just flat out a steel cylinder. And so if we take a look at what does this do, it allows rotation of the girders for sure. It is not restraining it. It allows the girders to grow and shrink. So we can have that longitudinal movement. And then transverse, again, we'll say this one probably does not. It probably has some of those little steel pins in it to try and keep it from going side to side. With a lot of these steel bearings, I guess one thing I would mention is that they can be highly unstable when they get to seismic loadings. So a lot of these examples and a lot of the bearings in our inventory across the country were built before we had seismic standards. So this is a more complex bearing system. This is a roller bearing, but we call it a nested roller bearing. And so this is at the end of a steel truss. And so steel trusses are longer. The longer your bridge, the more that it wants to expand when it gets hot, and the more it wants to shrink when it gets cold. And so the range of movement on these is typically a lot more. And the loading coming through them is also usually a lot more because you have that long span bridge. So instead of just a roller like we saw in that previous picture, this one has 5 rollers underneath it to help spread the load out. And then they kind of put a plate across all of them to pin them together so they all roll in one big nest together. So if we look at this one, say rotation, and said, well, you know, we have this big nest down below that can't allow any rotation. So what they did on this bearing is they actually have a pin up above as part of the bearing configuration that allows that rotation to occur. Because again, you don't want to fight those loads. So it allows rotation. And then if you look at it here, it definitely is allowing that longitudinal with traffic expansion and contraction, and it's to some pretty high loads or high ranges of movement. And then when you look at the transverse direction on this one, say no, and what you can see is that you can kind of see that this whole thing is embedded in kind of a grooved channel, so that those bearings, you don't see the very bottom of those rollers, and what that is that's to restrain it from moving side to side. And here's a more modern type of bearing. If you are a maintenance worker, these are likely your favorite bearings because you hardly ever have to do any maintenance to them. These are elastomeric bearings, and they're basically a big rubber or modified rubber that has a bunch of steel plates stacked in it. Some of them are unreinforced, those are usually pretty thin, but something like this where it's really pretty big, this is going to be a steel reinforced bearing, and it just squishes back and forth under the loads. So this does allow some level of rotation. Again, that rubber can squeeze a little, so when the loads come on heavy to the right of the page, it squishes down, and then to the left, it'll expand out just a little bit to allow it to move. And then longitudinally, this also allows it, like it squishes to the right and the left as it deforms and allows it to move. And then transversely, we're going to finally get one that says yes, this one can move transversely as well, again within the limits of the of what that pad can stretch to. That's usually about half the height of the pad. And then here's a much more modern bearing. This one is a base isolation bearing. And so this is really, although it does allow movement, some movement under its normal loading like the other bearings, this is really intended for a seismic application. So when you have a big earthquake hit, instead of trying to make the superstructure of the bridge strong enough to resist all the earthquake loads, what this does is it says, hey, I'm going to make a disconnect between the ground and the bridge, and we're going to let it move separately. So this bearing here, the notes I have on it says that it can move up to a foot in just about any direction under that earthquake loading and still maintain its ability to hold the bridge up. So it allows rotation, translation, all the directions. So with that, I'm going to go ahead and hand it over to Jonathan, and he'll take you through some of these fun photos on what happens when bearings do not work. So Jonathan, I'll kick it over to you. You should get a pop-up on your screen now.
Show my screen.
Okay, and we are seeing your screen, but we're not seeing the presenter view just yet.
Okay.
Perfect.
Okay, there we go, guys. So I'm going to talk about bearing problems. The first one being frozen due to transmit tremendous forces. So that's your thermal expansion during your heating and cooling cycles. In bridge, I've actually seen quite a few misalignments. So when they do replace your bearings, make sure you go off the temperature chart. I know in NMDOT, we have one in our specifications, and I'm sure most of the DOTs have that as well. Movement beyond capabilities or material failures. So just remember your steel is going to be a little stronger in tension than concrete, actually more than a little. So your concrete can bust near the bottom of the bearings. So common bearing problems is corrosion. So if you have steel bearings of any sort, this should come up on your inspections. And this would be loss of section area, especially on the picture on the left. So it should put it in a condition state that it needs to be evaluated. And here we are. Well, hold on. On my screen, sorry guys, it just comes up as two big blocks here. but it's saying that there's forces up and down, and then it can move left and right as well. And on the picture on the right, you can see that it's already pulled that way, and it's not aligned. So bearing problems, too much movement. So this is exactly what I was talking about between the steel and the concrete. So your steel is going to bust the concrete first. So you should be able to monitor this as you go. So this is probably due to thermal expansion, the heating and cooling cycles that are on regular, well, on bridges in general. And here are some of the pocket guides. So concrete bridge deck patching, repair of concrete structures elements, spot zone and overcoating existing bridge coatings, bridge cleaning, thin polymer bridge deck overlays, think of an epoxy overlay in that case, and removal and replacement of bridge coatings. So there's a little bit everything from concrete to painting to let's just clean the top of the bridge.
Yeah, and there's even more pocket guides than listed there. That QR code, and we'll show it more than once here, is a good opportunity to download them, but they're really handy little guides.
And I'm going to say this, they actually have a lot of really good pictures. So like if you've got a new inspector, some new maintenance guides, these pocket guides are user friendly right off the get go, depending on, you know, it's not even depending on your level of bridge experience.
Mm-hmm.
So intent of the pocket guides. Installation guidelines, equipment and tools, limitations and restrictions, avoiding potential failure mechanisms, recommend training and required technical support and quality control. So like I said, it's got a wide variety of everything. You can see by the upper right picture, someone putting joints together. And then on the picture on the left, you can see them taking off a thin deck overlay, excuse me, and kind of go from there. So bridge maintenance, keep it clean and free of debris. So this shows some debris and of course some corrosion. I'm sure everyone has the same problem that we have in New Mexico of pigeons, and it can be pretty thick. Spray those off, make sure your guys are protected. And then if you need to recoat your bearings, in this case, a paint job goes a long way. Bridge washing. Okay, so of all the people probably in here, we have some that probably live in some colder climates. And so I'm thinking de-icing salts, even the ice slicer that is used in New Mexico is extremely corrosive. I'm hoping that on the bridges that you guys have, that there's some drain holes and you guys will be able to just wash it and spray it down. So flushing and washing reduces the potential chloride intrusion in the deck. So chloride intrusion is when the salt is getting into your rebar, and then it will cause it to rust, expand, and then you will end up with delamination and spalls in your concrete deck. It's essential for proper joint and bearing movement. So cleaning the joints is also very, very important. Now, my preference on cleaning the joints is with just compressed air. That way it doesn't get too much, well, it doesn't tear as much as if you were spraying it with a water hose. And then also this extends the life of your steel coating system. So if you have steel bridge rail, and then the plates that keep the rail in place, this is a really key thing to keep those up and going.
Mm-hmm.
And
I'll add, I'll add just real quick that maintaining those joints above your bearings is one of the best ways to keep your bearing from looking like the one in this photo, right? That had to have a leaking joint above it for a long time for it to accumulate all that.
And I will add something to that as well. I have came across a bridge joint that literally had a tree that was probably about 5 or 6 years old growing out of the joint, not underneath the joint, but out of the joint. And the maintenance personnel told me, oh yeah, we cleaned it every 3 months. And I was like, I don't think that's possible. So things to consider: follow state and federal regulations. Some debris might be hazardous. So if you guys have any lead-based paint systems, make sure you're not spraying the lead-based paint right into a protected stream. In New Mexico, we have protected trout waters, so we've got to be extremely careful about what we're washing into the streams. Sweep and collect large debris for disposal. That could be anything from trees that are coming down, debris. We've had a lot of flooding, so I have a lot of debris stuck in my joints. Flush during high water flow to minimize environmental impact. Clean on a regular cycle to avoid large buildup with hand removal. So one of the things I like to put on the regular cycle is if you guys do have some flooding that your bridge does go all the way to the joints, try to clean it as soon as possible. And okay, so a user's guide to maintenance and repair of bridge bearings. So it kind of goes over the types of bearings that everyone was talking about: the sliding, the rockers, the roller, the elastomeric bearing pads. And then it goes into preventive maintenance. So that should be performed by your maintenance crews. And then bearing repair, the jacking of the superstructure and resetting of bearings. So that goes, again, make sure when you first build a bridge and you are setting brand new beams down, that it is put in place, the correct place to start with. Now, if you do any jacking and shoring plans, so let's say for bearing replacement, again, go off those thermal expansion charts. So some of the common maintenance on them: the cleaning, maintain proper function, reduces the chances of your bearing freezing up and locking up. I've had some bridge joints that even in, it was -5, it was fully expanded. So I kind of knew that the bearing was completely frozen and locked up. And I had the same picture of it in 100 degrees and it didn't move. So if the bearing is frozen, the bridge maybe need to be jacked to facilitate the removal, cleaning, and repainting before reinstallation. So when you jack up a bridge like that, you can either replace the bearings or do the maintenance as you go. Anchor bolt tightening. So loose anchor bolts may cause damage to other components of the bridge in addition to the bearings. Retighten the anchor bolts as directed. So that's in your installation. And then also as the years go by, they can loosen up. Now I prefer to put a lock nut on top of it, especially when we're doing maintenance. Ooh. So bridge painting before. So this is corrosion, and I would consider that with section loss. And that's what it looks like afterwards. So they can clean up all the corrosion and then do a repainting. And one thing I do want to notice is they changed out the bolts, and you will see 2 nuts on top of it. So when you do your maintenance on that, make sure your bolts are tightened down and with your nuts.
Yeah, and it's harder to see in that photo, but you could, in the one before that, that rusted plate is actually shifted over, I don't know, maybe 3 inches as it kind of stair-stepped its way to the right there. And I think that was a result of those anchor bolts failing.
And
then nice lined up, yeah.
So bearing lubrication, jack to provide clearance, clean first by flushing, power washing, or compressed air. Lubricant can utilize grease, oil, graphite, or directed. Some bearings have grease fittings. In our dry climate here in New Mexico, we use graphite because if we use any type of grease or oil, our wonderful dust storms here can lock things up pretty quick. So make sure you have enough clearance when you jack it up to get all the debris out, and or if you need to realign your bolts. Sliding plate bearing maintenance. Slightly round one bearing surface to reduce binding. Add a thin sheet of lead between the plates. I know in New Mexico we don't do the lead anymore, just due to environmental considerations. Reduce friction with self-lubricating bronze or PTFE pad and a stainless steel mating. So you can see the slotted holes, the masonry plate, and the sole plate on this one. And then the rolling bearing maintenance. Hard to maintain, keep areas clean and painted, limited access, lubrication, remove and refurbish. I have not seen any of these roller bearings or nested roller bearings installed on new bridges, but on the old bridges, the hardest part I've seen is the corrosion. So try to keep it as clean as possible. Again, the pigeons are not your best friend in this one. So definitely clean it up as best you can on every maintenance cycle. So the rocker bearing maintenance can be unstable, be on normal movement, keep clean, lubricated, and painted, and remove debris. This is again a pigeon's wonderful home. I've also had owls and hawks create nests around these. So remove the debris to the best you can, and also maintain and go off the temperature chart to see if it should be vertical or extended or pulled in just a little bit. Please put those on your inspection reports. So then we have the elastomeric bearing maintenance. Elastomeric pads with or without embedded steel plates. Maintenance is rarely necessary unless it walks out of position. So if you do have any seismic events, in New Mexico, we're starting to have some seismic events right on the Texas border in our oil field. And so the pads can actually walk out. I have one bridge right now that the pad has completely walked out, and I've seen a drop of 2 inches in the deck of the bridge. Install keeper plates. So exactly what I was talking about with the seismic parts. If you put, I've always called it a keeper bar, but if you put a keeper plate right there, they shouldn't walk out as bad. Now the elastomeric bearing pads can tear and split over time. So that's one of those things to notice during your inspections. And the other thing I would also say on the elastomeric bearing pads, if you are going to do any type of welding, say on the keeper bar or the masonry plate, make sure to protect that pad. So on the bearing replacements, consult an engineer, lift all beams at once, avoid damage. Most old bridges are not designed to facilitate the jacking plans. Now, the one thing I will say on the bearing replacement is jacking and shoring plans are usually required to be stamped by a PE, depending on your state specifications. And you can do this with a live load, even though most places will at least get really cautious when it comes to having it with a live load or just having the regular dead load. Now, I've done some where on the live load, I could not do it with a live load. And then I've had others, that was the only way that it can be done. So make sure that you get someone that knows what they're doing and it has a stamp on the plans.
Yeah, jacking the bridges is highly technical and also really cool. And I get the pleasure of actually walking you guys through an example of bridge jacking. This slide here, this third bullet where it talks about how most old bridges weren't designed to facilitate jacking. I would disagree. I would say all of them weren't designed to facilitate jacking, and some of them accidentally gave you a place to jack from. When we kind of go, let me see just real quick, Jonathan or Jason, can you guys confirm that you're seeing my steel truss slide now?
Yes, sir.
Excellent.
Yes, sir.
This is the example of all the work that went into doing a bearing replacement on a steel truss. You can see that there's a lot of, there's some false work built in here to give them access and lots of additional steel beams installed. In that previous slide, you saw that we had some additional steel plates being installed, and all that is really coming around to the fact that you're trying to take a tremendous amount of weight from the bridge and put it into a spot that it wasn't intended for, so that you can then get your bearings out and do some work. And so I I've been involved in a few of these projects. They're really fun from a technical standpoint. But again, as you work through all your constraints of what you can and can't do, just a word of caution that these are one of the more complex kind of projects that I've seen maintenance crews tackle. I'll run through some slides here of a case study, an example of a bearing replacement. This is the Mission Bridge in Oregon going over I-84, and it's a really long, highly skewed post-tension box girder. And so the issue that we had on these is at the abutments that you can see on the left and the right there. And let me get a little better view of it. You have 5 bearings underneath this box girder to accommodate the expansion and contraction at those locations. And what we had is they had steel rocker bearings in them, and we had some really poor construction. So typically those surfaces should be parallel with each other on either side of the rocker, or pretty darn close to it. And here, I mean, they didn't even try a little bit to pretend that they were going to be parallel. You can see that top plate is off at more of a skew, and then the bottom, actually the abutment was fairly level. So that was actually not too bad. And so what happened is over time that out of plane force caused that upper, the pintles, the little steel rods that held the bearing in place to shear off. And so this bearing was slowly walking itself out. And so this kind of red line that I show here is where the bearing, that top rocker started. And now we've showed where it's moving to. So our thought was over time, eventually, this was going to just fall out and you were going to have a loss of bearing and potentially some serious damage to your bridge. If you can imagine, you have such a long span and you just take the bearings out of one side, it's going to try and bridge over that gap and crack your deck and your girders up over that interior support. So kind of jumping forward a few slides in our process to kind of show you what we're talking about is, so that's the steel rocker on its side once we got it out, and you can see those 2 little steel dot or round dots kind of in the middle of that plate. When I'm referring to the pintle, is that little steel piece that's in his hand on the right, and that's what helps hold that top of the rocker in the right alignment. Right, if everything was nice and parallel and done really well, then that pintle shouldn't be seeing very much loading on it. But in our case, it was actually shearing off due to the movement. So when you're going to remove those, right, the first thing you got to do is lift the bridge to get the load off of them so that you can take them out. And in this case, it required 4 200-ton jacks in order to lift the bridge. So there was a lot of analysis that went into here. We're actually kind of fortunate here that the end of this bridge had a really big concrete beam kind of running along the same plane as the bent. So we had something strong that we could lift to. And then you had the abutment right there, which was a big mass of concrete that we could put the jacks on. So aside from designing and running the numbers to say that the bridge would be okay, we didn't have to do a ton of work to find a place to put the jacks. So unlike that steel truss example I showed before, this one was a little bit more straightforward from that sense. Now, it still was a big lift, right? So this is took 4 200-ton jacks to lift it up. We were not able to get approval to close the bridge during this work. And so what we did have to do is, while it was being jacked, we limited traffic to a single lane down the middle with flagger controlled to slow them down and limit how much impact we had. Here's just another example of getting those jacks in place, right? You're putting a lot of weight into those jacks, and so you have some pretty heavy duty steel plates that were required to be above and below the jack to help spread the load out a little bit. I don't think you can really see it in the photo, but between the steel and concrete, there should be a little thin layer of elastomeric to kind of help distribute any localized kind of defects in the concrete and spread that load out. And then if you look at the photo on the right, you know, this bearing work was going to take some amount of time, and we didn't want to leave this and on the jacks while we're doing all the work. So it's pretty common to see a block out that's included along with the jacking plan. So you lift it up high enough to do your work. I did see a comment in there that asked, hey, how high can you lift these, right? And it really depends on your bridge. So I've always given guidance in the plan sheets of, you know, don't lift this one more than 1/2 inch, or don't lift this one more than, you know, some of them you can lift away. So there's some that I've lifted 2 inches because that's what they needed to get clearance. On this one, since the bridge is continuous over that interior bent into the next one, as we lift it, it actually starts to stress the bridge, and the bridge itself will start fighting you and keep it from lifting. Well, it'll start raising the load as you start lifting it higher and higher. So that's another thing that we've done on these is give an actual lift-off loading. Like at such a load, we should start to see this bridge move. Engineers never get the number exactly right, but if you're like 50% over the load they said it should be moving at, then that tells you one of 2 things. One, something's binding you up and it's not breaking free like we had anticipated, or 2, the numbers were off. But either way, it warrants a phone call back to the engineer once you start getting above what they had anticipated it moving at. I wouldn't probably wait to 50% either. I would be chatting with them much quicker. So anyways, once you get it jacked, and then you can set it back down on these big steel block outs that, you know, we don't have to worry about hydraulic pressure or anything holding the load while they do their work. So the whole point of these is that we don't want to end up stressing the bridge when we're done, right? We want those new bearings to fit the hole just right for the old bearings. And so what the crew came up with here is they had these dial gauges that they installed, and they installed them in multiple spots across the bent. And so once they lifted it, you can see here it's like 0.335 inches that they had lifted. And so once they're done setting their new bearings, getting their work in place, and they unload it, we would like to see that number come back to real close to 0 so that we know that we got back to where we were at. Any good maintenance worker to only trust technology so far. So over on the side there, you can see a scratch gauge where they have a steel plates just basically bolted together where they could just put a pencil mark of where did it start and a pencil mark of where it went to. And so those plates should come back into alignment when they're all said and done. Here's a photo just kind of showing here we got the bearings out. And you can see those little kind of corroded steel pintles off to the side there. These are big hunks of steel. They're very heavy. Otherwise, I was going to try and get one as a souvenir, but it's too heavy for me to lug around. Once we get the rocker bearings out, you still need to address the fact that you had this really crooked surface to start with, right? And so the original plan was just use a chipping gun and chip back into there until you could get to the little steel anchors that are welded to the top side of the plate, and you could torch them out. That was the plan, at least. You can see there's very tight working windows here, and that steel plate, you can kind of see the corrosion line, right? Like it was embedded back into the concrete a ways, and so they kept chipping at it, and the bridge crew came back with, hey, I think we have a problem here, and we're gonna try and come up with a better or different way of removing these. And that's where they came up with a wire saw. And so this was really pretty cool. You can see here the setup, and it's basically a pulley setup where they can get it up real tight, flush to the bottom of the box girder. And here's a picture of it kind of in action. And you can see it actually cut through not just concrete, but steel at times as well when it needed to go ahead and give us a nice flush surface and get that top bearing plate out of our way. The only real trick that they found with these is that, you know, to get the wire saw started, what you needed to do is get in behind the plate to give you a spot to start and create a little notch. And I kind of highlighted here. So you can get your wire started there and then pull it and cut it pretty flush. It was a really pretty slick operation. It saved a ton of time. I think I remember the crew calling and asking, you know, well, it's going to be this much money. And it's like, well, you think of how much labor it was going to take to actually try and make this work. It was going to be a lot. So so they just used a little grinder, get the notch started, and then they used the wire saw to cut it out. What we decided to go back in with was elastomeric bearing pads. ran some calcs to figure out how thick it needed to be in order to accommodate that range of movement. We also ran calcs on, we had a note on some of the previous maintenance slides that the really only issue you ever have with these is the bearing walking out. And what that means is that you didn't have enough weight sitting down on these bearings as they went back and forth, and so it could actually slip a little. And as it slips, then it could start to walk itself out. We did not have that problem on this very heavy post-tension box girder bridge. It had a lot of weight, so we didn't have to design any kind of keeper bars on it. But this bearing is not the same height as what we took out. So what we did is the crew went in, and you can see those pedestals that are now built. So that was some reinforcing in concrete that was put together and poured to pretty tight tolerances for them to get the height just about right for them to get these set. So they got their new pedestals in, they're starting to set their bearings back into here. You can see the bridge is still being supported on those steel plates there as they're finishing up their work. But, we gave them that, they jacked it that 0.3 and change inches. You can see there's not a lot of gap above that bearing pad. So you start thinking of construction tolerances, and these are really pretty tight. I was really impressed with how well these were able to line up when it was all said and done. But when you have something that's this stiff, this big steel or a concrete box, it doesn't want to give much. And so if one bearing's set even maybe a 1/4 inch higher than the one next to it, the one next to it might not actually come down. The bridge may not come down and sit on it. So here's the crew taking some of their final measurements and getting everything lined up and ready to set it down. And then from there, they could just go ahead and start unloading the jacks very carefully in a controlled manner and set the bridge back down. I don't know if you can see in the photo there, but the dial gauge came back to all zeros with a 1 on the end of it. So they ended up really kind of hitting their target of getting it set back down and at the same elevation that the bridge started with. So that's as far as, that's all of our slides. Let's take a quick peek at some of our questions and see how we're doing. Jason, I know you've been doing a good job on keeping up. How are we looking on our questions?
Yeah, I'd like your feedback on how long does it take to replace a bearing and bearing plate?
So the example that I just showed there, that took the crew about a week to complete that work. I would say that the answer is highly dependent on what you're doing. So if you have like that steel truss where they had to do all the different that work going into it, then it could take much longer. And I'm trying to think, if you're just like lifting the bridge and pulling one part out and putting the same part back in, that might be pretty quick. Right, maybe something you could even accomplish in a nightly closure. But if you have to pour concrete for that new pedestal, which you often have to get your tolerances and alignments right, then you at least have to wait for your concrete to cure.
Yeah. If they're installing new anchor bolts and they run into rebar, what do they do?
I would make a phone call to whoever put the design together. But typically I would hopefully prioritize the anchor bolt over that piece of reinforcement, but I would want to look at it first to see where else I have other steel that's going to help transmit loads. Because, as we saw in one of those photos early in the presentation, that was loading the anchor bolt caused that whole ledge to fall off. So having less steel there is not great.
What do you do to maintain isolation bearings?
If you have isolation bearings, they are probably new enough that they come with a maintenance manual. I'll admit that my maintenance background are on all the old bearings. I've never had the pleasure of having to fix a new one. How about you, Jonathan? Do you have any thoughts on isolation bearings?
Not too much. All the isolation bearings I've had are very new, like we're talking 10 years or less.
Yeah.
So I can't really give a lot of guidance on that one.
Yeah, keep it clean. I mean, that's the guidance we give on every bearing, but I'm sure it's true with the isolation bearings, just as with all the other ones, is keeping it clean would be your best bet on having to do corrective maintenance at least.
Have you ever used stainless steel on your bearing plate to eliminate corrosion?
You see stainless steel paired with like a sliding plate fairly often to try and minimize friction between the two. Honestly, if I'm installing a new bearing, I'm using elastomeric that won't corrode.
Yeah.
If I did have to use stainless steel, I would want to check the compatibility of it with whatever I'm bolting it to, because I'm sure the rest of the bridge isn't stainless. But if you had to do steel bearings, I would certainly encourage you to look at materials that won't corrode, because I know that replacing them is a challenge. So it certainly would seem like a spot where spending more on materials would be worthwhile. There's a note or comment here, at least, that new bearings are so much bigger than existing. It depends, you know, those like roller nests and those big rocker bearings, those take up a lot of real estate. So usually on those, I've had to close the gap to my new elastomeric pad with some kind of a concrete pedestal. So not always, but you know, the new bearings are going to be sized for a lot of us seismic loading. And so they're just going to be bigger and more complex. They're really pretty cool. I wish I had the video of that bearing test with the one that moved a foot in all directions. It's wild to think that as it's doing that, it's still holding the bridge up vertically.
When would you pick a steel extension or a steel pedestal versus a concrete pedestal? I've used both. I just, for me, it was just a comfort level of the DOT I was working with. There was a DOT that preferred steel pedestals, and then there was another one that prefers concrete. So I've never really thought about why.
I might be able to kick in on this one a little bit.
Mm-hmm.
So I've used both before, and a lot of it was driven by the existing reinforcing in the abutment.
Yeah, I was gonna say I would look at the abutment too. If I had a steel crossbeam or something with the bearing on top of it, then I would be more inclined to keep it with steel. I like concrete, especially when I'm contracting it out, because I think it's easier for them to correct grade issues and get it back to level. Or at a minimum, it puts it all onto the contractor of, you know, I gave you the ability to grade any surface you wanted. You were supposed to make it parallel to the surface above it.
Oh, lots of questions on anchor bolts. You know, what do you do with bent anchor bolts? Can you straighten them out? And what do you do when the anchor bolts have damaged threads and you can't get a new nut on them?
So I've seen us try and weld anchor bolts back together. I've seen a lot of those welds fail. Have I seen us try and just bend the anchor bolts back? I don't know that I wouldn't be opposed to trying it, but I would also keep an eye on that anchor for cracking in the future. Anchor bolts are tough because not only can they take some pretty large loads, but like if you want to go and take it out and install a new one, you still have some anchor left in the hole that you're trying to get back to. And you usually have very little height to do any kind of drilling as you're trying to actually install it. So like I've tried to use like angled drills kind of a stuff, and then have them try and keep changing drill bits. But even with that, you can only get so far. I would be more inclined to try and come up with a different keeper system as a potential option.
Travis, have you guys ever drilled them out and then epoxied them back in?
That would be something I would consider trying. I think some of the issues I would have are, like I mentioned, is that you still have the steel in there that's really hard to drill out. There was a question here on, do you have to lift the entire superstructure at once in order to do it? And I would say that that is something you need to look very closely at in the design for it. Generally, lifting the whole superstructure is a good idea. Certainly, if you have like, and if you're not going to do it, then you need to be careful on what happens to the rest of it. So like I can think of an example where we had a really wide bridge with a bunch of pre-stressed slabs. And what we did is, and just a few bearings had walked out. And so they really didn't want to have to lift the whole thing. And so what we did is we came up with a steel beam that went and bridged across where the bearing was, and it was kind of flexible. So at the end of the beam, it was like a big cantilever. At the end of the beam, we didn't think it would really move at all. And we kind of used the steel beam to gradually, slowly transition just above that one bearing. So you could get it out and back in and then set it back down. And it didn't cause damage. But again, that was something that you had to be careful with, because if you jack just one part of the bridge, you're can put a lot of load into another part, and may not have been intended.
Yeah, I would say that when you're only jacking like a steel superstructure, a 1/16 to an 1/8 of an inch just to unload the bearing, it's pretty low risk. There's a question in here about when you take traffic off versus leaving traffic on when you're jacking.
My first answer is take it off. And then if mobility comes back with it as absolutely no way can this bridge have traffic completely removed, then you work through solutions on how to do it. But my suggestion is getting traffic off is not a bad idea ever.
For a temp support situation where we're gonna put a column underneath a beam, we still take the live load off the bridge during the jacking operation. And then after that, it just depends on the superstructure itself, and can it handle the load in the new support locations if you can put the live load back on. And it always comes down to, I mean, I just recently did a temp support where we looked at it and there is absolutely no way traffic can go on this bridge while it's being fixed. And they wanted it fixed, and they're like, okay, well, we'll just live with the traffic off. So
you think like the answer I got back was, it's just leave it broke. And I'm like, that's not my plan A.
The one thing I am going to put on this is I've actually had a bridge shift as we had a live load on it, and it did the diaphragms because it twisted. So I agree with Travis. If you can keep traffic off of it, do it, because there is nothing scarier when to be under a bridge and have things start popping.
Yeah.
Oh yeah.
Yeah, and it depends on the underclearance. You might want to think about having traffic not under it sometimes.
There was a question in here about, are there any special topics to consider when working on a pier or a continuous span, particularly when access to the pier can only come from the bridge itself? So certainly in a continuous span, the comment I made before of, as you start jacking, you're not just lifting the weight of the bridge now, but depending on how high you need to jack, you start actually having the bridge fight you itself. So that's something to be paying attention to, depending on how stiff that superstructure is. And then the fact that you're at a pier is, I mean, you probably have limited access. And so that's just the real hard part of all these bearing projects, is they just didn't think about us when they built it.
And if you're jacking off of the top of the pier cap and it's just like a regular reinforced concrete beam almost, pier cap, not a solid wall bent below, just you really need to analyze that pier cap for the new locations that you're jacking as well, because you could induce shear cracks in the pier cap that need to be replaced, especially if you've got like a large piece of construction equipment right on top of that bearing location. So.
Mm-hmm.
We've had that before where, you know, the construction equipment has caused shear cracks at the new jacking location. Then we've had to, you know, after the project, repair the pier. So.
There was a comment about how do you prevent elastomeric bearings from floating? Elastomeric bearings are held in place either by the weight of the bridge. So a lot of like your big concrete spans have enough weight to just keep them from moving. Or you can install some keeper bars. So it doesn't take much of a lip of a steel bar with some anchors in it to keep that bearing from wanting to move at all. And so there's actually calcs that the engineer should be running to give guidance on will it likely walk or will it not. There was a question about replacing the PT-FE spherical bearing in a bridge hinge where access is limited. You know, it would be really specific to that bearing design, but I would guess that you need to remove the entire component to be able to take it apart external to where the bridge is to replace it to then put it back. But again, it's really going to be specific to what your situation is. I just have a hard time figuring that you're going to lift your bridge high enough to do it all while it's in place.
Yeah.
Oh,
I was just getting ready to answer that question online with that's probably going to take an email with some pictures to either to both of us. So if they wanted to go that route.
Yeah, for sure. Feel free to send an email.
Yep.
All this stuff is interesting. How long will elastomeric bearing pads last? I've only ever replaced ones that have been incorrectly designed for the range of movement. I don't know how long how long they've been around. I don't know, Jason, do you have a number you'd throw out at it? A long time.
Long time. I mean, I haven't replaced any that were properly designed. They usually are under designed and over rotate and squash, and I've replaced those, but nothing that's been properly designed.
I'm gonna throw it out there. We have a 25-year rehab cycle, and I have not changed out a single elastomeric bearing pad before the 25-year cycle has hit.
So you guys replace elastomeric pads after 25 years?
Yes.
I mean, are they in a condition that requires it, or it's just part of the standard procedures?
It's more standard procedure than anything else, but we have had some rips and tears just due to improper calculations for thermal expansion.
Yep.
Yeah. Okay, we are at 10 o'clock. As always, you guys are a fantastic audience.
Yes.
Everyone that's on the registration list will get the email kicked out in about a week or two with the video recording and our PowerPoints. I did not see any recommendations for future trainings. So if you have one, please feel free to shoot Jason or I an email here and we'll put it on the list. And if not, again, just wanted to thank you guys. I wanted to thank Jonathan and Jason and everyone. Have a great rest of your day.